Right now, Kepler 78b is still orbiting its star every 8.5 hours, inside a zone where every law of planetary physics says it cannot exist. And the scientists at NASA, Harvard and Caltech who have studied it for over a decade have no model, no mechanism, and no explanation for how it got there. And what they found when they looked closer is the part they're afraid to say out loud. Kepler 78b sits roughly 400 light-years away in the constellation Cygnus. It's a rocky world, dense, Earth-sized, orbiting a sun-like star at a distance so impossibly close that its surface temperature hovers around 3,000 degrees Fahrenheit. It completes one full year in 8.5 hours. Not days, hours. The Kepler Space Telescope found it in 2013. Astronomers were puzzled from the first dataset. A planet this size in this orbit this close, it ticked every box for impossible. But there it was, undeniable, stable for now, circling its star like it had always belonged there, except nothing in our understanding of how planets form says it could have. The moment astronomers ran the numbers ran out. And that's where this story stops being interesting and starts being terrifying. Planets don't form where Kepler 78b sits. That's not an opinion, it's physics. When a solar system is young, the region that close to a star is far too hot. The material needed to build a rocky world, dust, ice, silicate rock, vaporizes before it can clump together. There is no mechanism by which Kepler 78b could have assembled itself at its current location. Not one. So it must have migrated, drifted inward from a safer distance, slowly spiraling closer over millions of years. Except that theory breaks too. To migrate inward, a planet needs to drag through a disk of gas and dust surrounding its young star. That disk acts like a brake, slowing the orbit, letting the planet fall deeper in. But Kepler 78b is so close that a disk of that size would have extended into the surface of the star itself. The math collapses. The migration model requires a disk that couldn't have existed. And without that disk, the planet has no way to have traveled here. The two most respected theories in planetary science, in situ formation and disk migration, both fail for Kepler 78b completely. So scientists reached for a third option, gravitational scattering. Maybe something knocked Kepler 78b violently inward, a rogue planet, a close stellar encounter, a catastrophic collision in the system's early history. It's possible, but no evidence of that disruption exists. The star is calm. The system is quiet. Whatever happened left no fingerprint, and that silence is exactly what worries the researchers who can't stop watching it. Because Kepler 78b isn't just impossible to explain. It is actively, right now, doing something that shouldn't be possible either. Its orbit is decaying, slowly, quietly. With every single pass around its star, Kepler 78b is losing ground. Tidal forces, the same forces that pull our ocean tides, are working on this planet from both directions simultaneously. The star's gravity stretches it, deforms it, like invisible hands pulling at both ends at once. And with every deformation, energy bleeds away. The orbit shrinks. The planet gets closer. In roughly 3 million years, a blink of cosmic time, Kepler 78b will spiral all the way in and be swallowed whole. But here's the strange part. It shouldn't be possible at all. The tidal decay we're observing doesn't match the models. The rate at which this planet is losing energy, the way its orbit is tightening, runs ahead of what our equations predict. The numbers don't add up. The planet is moving in ways our best tidal physics cannot fully replicate. And that gap, that small, unsettling deviation between what should happen and what is happening, is exactly the kind of thing that rewrites textbooks. It means either our model of how tidal forces operate is incomplete in ways we haven't mapped yet, or Kepler 78b is being influenced by something we cannot see. Something else in that system. Something pulling on a planet that has no right to exist, in an orbit we cannot explain, in a way our best equations refuse to account for. If Kepler 78b breaks formation models and tidal models at the same time, the implications ripple outward fast. Because planetary formation is the bedrock of how we understand every solar system, including our own. If a rocky, Earth-sized world can appear where it has no right to exist, in an orbit that defies every stage of its expected history, then our entire map of how planets are born, how they move, how they die is incomplete in ways we haven't measured yet. Here's what makes it worse. Astronomers have now found more than 50 planets in this same category, ultra-short period worlds, blazing close to their stars, all of them inexplicable. Kepler 78b wasn't an anomaly. It was the first warning. And with 50 more lined up behind it, the question stops being how did this one planet get here? The question becomes something far more unsettling. What if our entire model of how solar systems form has been wrong this entire time, and these impossible worlds are the universe's way of finally telling us? Kepler 78b is still up there, still spiraling, still defying every equation we have. So what do you think is really going on? Drop it below.